Okay, guys, in this video, I'm going to explain how to find velocity and position based on the acceleration. So here the acceleration vector is given, and it looks like that's just I plus e to the power tj. Now, they also give you initial condition, and that's because you cannot determine the velocity and position um, because you're going to have that plus c thing, if you remember. So you need some initial conditions to determine them completely. So the velocity vector should be 6j, and the position vector at 0 should be 3i. So let's see if we can determine it. And I think I have a method that is not going to be as painful as some of these other videos. So for the velocity, you want to take the integral, right? So you want to think about, okay, what do I have to differentiate to get 1? Well, that would be t. Okay, so that would be ti. And then remember that e to the t does not change as we differentiate or integrate. So that would have been the final answer, but unfortunately, you're going to have to add some constant, okay? And this is not just a constant like a number, but a constant vector. However, there is like an easier way to figure this out without actually trying to solve for things. Just, okay, so just put t here, e to the power t over here, and just plug 0 and see what you get. So if I plug 0 for t, I will get 0i, right? Which is fine because my velocity at 0 should be 6j. So the ith component should be 0. That's good. Now let's plug in 0 over here. Well, e to the power 0 is 1, and it's not 6. So I would need to add 5 to make it 6. And that's it. See, like it's not that hard. Okay, now let's talk about the position. So now that we found the velocity, so now we're going to take an integral again. So integral of t is going to be 1/2 t squared I. And then integral of e to the power t plus 5 is again going to stay the same, and 5 becomes 5t. And again, it would have been the answer, except we have this other vector, let's call it C2 or whatever, that will need to be determined by the initial condition. So let me just put it without the vector, and then I will go over how you find those constants. Because it's basically boils down to just adding some numbers here to match the condition. And just numbers, no t's, okay? So my r of 0 should be 3i. If I plug 0 in here, I get 0. I don't get 3, so I need to add 3. So that'll turn it into 3. And then over here, I need to adjust it so that there shouldn't be any j components. So if I plug 0, e to the power 0 is 1, and then 5 times 0 is 0. So this gives me 1, but I want nothing there, so I need to subtract 1. And if I subtract 1, now that I plug in 0, then I'll get 1 minus 1, which is 0, and that'll satisfy the initial condition.